Two angles actually are called complementary angles if the sum of the measures of each of the angles turns out to be 90 degrees. And visually, it's clear when, in fact, we have two angles that are complementary angles. What it means is that when you put those angles together from the same vertex, what we have is a perfect right angle. So now, given that we know that the measure of this angle is 37.2 degrees, let's find the measure of the complement of that angle. So what would the complement of that angle be? Well, we know that the entire angle I've drawn here has to be 90 degrees if this angle is going to represent the complement of that. And so therefore the whole thing is 90, and this here is 37.2, so this must be the difference. And so we must have 90 degrees minus 37.2 degrees. And so when I do the subtraction, I see 52.8 degrees. And so the measure of the complement, this angle right here, turns out to be 52.8 degrees. That's what it means to be complementary angles. There's another really neat idea. It's similar but slightly different, and that's the notion of supplementary angles. Supplementary angles, when we have two angles like this, where the sum of the measures of the angle actually equals 180 degrees. 180 degrees. How would I actually find the measure of the supplement of this angle? If this angle has measure 5x plus 49 degrees, what I would do is I would take the entire sum of 180 and subtract off that measure. And so I'd see 180 degrees minus 5x plus 49 degrees. And what does that equal? Well, that would equal 180 degrees minus 5x degrees minus 49. So I have 180 minus 49, and what does that equal? 131 degrees minus 5x degrees. So the answer is 131 minus 5x degrees. What does that mean? It means that the measure of this angle right here can be expressed as 131 minus 5x degrees, where this x right here is the same x as appearing here. Why? Because if you add that measure and that measure, you get exactly 180 degrees. Supplementary angles.